So Quicksort algorithm is one of the most popular algorithms we have in data structure and algorithm subject. The main key points that are to be remembered for Quicksort algorithms are: it is significantly faster than other sorting algorithms on average case, it is relatively more cache friendly, and it uses pivot element and partitioning method to get the result, sorted result, and it is also an in-place sort. So next we are going to discuss Quicksort algorithm in detail. So what is the main strategy in Quicksort algorithm? Divide and conquer strategy. Okay, divide and conquer strategy. Which takes more time, measured time, divide. In case of merge sort, just the opposite. Conquering takes more time. Okay, that means conquering means merging. But in case of Quicksort, divide takes more time. Division. Division to the subarray takes more time. There are some important points to Quicksort algorithm. One is that it is also called partition exchange sort. Partition exchange sort. That means in case of Quicksort, we will be having partitioning method. Every time we will partition the array into subarrays. Okay, that's why it is sometimes called partition exchange sort. Second thing is that already I told you that divide and conquer strategy it uses. Third important point is that it actually uses 3 steps: divide, conquer and combine. Fourth very important point is, which is a terminology which is called pivot element. Please write it. Quicksort means pivot, nothing else. Pivot element. Okay? Pivot element is important term in case of Quicksort. Based on the pivot element only, we will be partitioning the array into subarrays. So how to find pivot element, which element we should choose as a pivot element, that is important. Okay? So what is the catch in Quicksort? Very simple. Elements which are less than the pivot elements comes to the left side of the array, left side of the pivot element, and the elements which are more than pivot element will come right side of the pivot element. Clear? All of you? Meaning you are understanding or not? First you have to choose a pivot element, you have to scan the array, whichever elements are less than the pivot element will come left side of the array, left side of the pivot element, whichever element is more than the pivot element will come right side of the pivot element. So initially what will happen? Why it is called partitioning sort? Sort because it is something like this. Pivot element, initial choice of pivot element, then the element which are less than pivot will come here, and the element which are greater than pivot will come here. So it is like a tree structure, yes or no? Then again you have to, one pivot element you have to choose from here, again one tree will be there. This is how it will move. Again like this. And then lastly we will get individual elements sorted in proper position. This is a Quicksort algorithm. Every time you have to choose the pivot element, that is one catch. Which element will be the pivot element? So you can write it. Which element? Which element you should as a pivot, you choose as a pivot element, right? Whether you should choose the first element as a pivot element, this one, or you should choose the last element as a pivot element. What, Robin? What do you think? Which element, huh? First element? Middle element? There is no rule that you should choose always middle element. There is no, but people used to choose middle element most of the times. I can choose last element as a pivot element, no problem. Only thing is that after choosing pivot element, the scanning will happen, whole array. Whichever element is less than the pivot element will come left side. Whichever element is more than the pivot element will come the right side. Is it clear or no? Next time you will pick another pivot element from here, another pivot element from here. Similar process will keep continuing. Okay. Once you choose the pivot element that gets its proper location. First pivot element, whatever you will choose, that is a catch. It will get its proper position. It will be placed in proper location. Then remaining things, let us say from this subarray again you are picking one pivot element. That pivot element also will get its proper position. From this subarray also pivot element will get proper position. Like that all by and at last you will get individual element placed in proper locations. Wherever they should be in ascending order sorting. Is it clear or not? So this is increasing to decreasing or increasing order sorting algorithm. So at last you will get a sorted element, right? This is Quicksort algorithm. So divide and conquer strategy. So we are dividing it every time in 3 dividing. So dividing operation taking more time, combining is not taking at all any time. In case of master, this is just the opposite. Okay. So elements which are less than this is done. The choice of the pivot element can be anything. As Robin mentioned that middle element we should as a pivot element, not necessarily, but most of the time people choose middle element as a pivot element. I can choose the last element also as a pivot element. So let us say in case of quicksort algorithm that we are going to see the algo, let us we have chosen the last element which is the highest element in the array. Then in that case what is the situation? Shall we get any right subarray? Only left subarray only, right? So you understood. This is the algorithm for quicksort algorithm. So one is going for 1 to q minus 1, another is going for q plus 1 to r. Two algorithm has to be called, two functions has to be called. Partitioning function every time. So major component in quicksort algorithm is partitioning. You have to partition. So quicksort 2 times you are calling. One is p to q minus 1, another one is q plus 1 to r. Just now I have seen. Okay. Initial call to the quicksort is 1 to length, which is true. First element to the last element initial call. So this is the partitioning algorithm. This is my array. So first one is, let us say this is r, this is p. Okay, this is p, this is r. So a r represent 4. Okay, and p index has been assigned to 1, and then ith index is p minus 1. Minus 1, value of p is 1, so initial index is 1 minus 1 0. Okay. Now please run this algorithm and check how the swapping will happen. Okay. So I index is 0 and x is nothing but AR, that means A8, last one, which is nothing but 4. Value of x is equal to 4, value of I equal to 0, and then start from here. What is happening? You just check. J value is nothing but value of p is how much? 1 to 8 minus 1, 7, up to 7 it will go. Okay. So let us see what is happening in the first case. If aj, that means a1 is less than x, value of x is nothing but 4, value of 1 is nothing but 2, 2 less than equal to 4. Okay. So if this is true, then index of I will be incremented by 1. So index I is nothing but 0. So it will be 0 plus 1, 1. Okay. And then exchange AI and AJ. Exchange AI and AJ. So value of AI will be A1, and you have to exchange with AJ, J also 1. So first iteration 2 itself is exchanged by itself, which is meaningless. 2 is exchanged by itself. So second iteration, what is happening? Just checking. So J equal to 1, J equal to 2, J equal to 2. What is happening? A2 is compared with, so A2 is nothing but 8. 8 will be compared with 4, which is false. 8 is not less than equal to 4. So in that case, what will happen? Nothing will happen. Again, the value of J will be 3. Yes or no? Value of J will be 3. I'm just seeing. So J3 is nothing but 7. 7 will be compared with 4. So here I think we have picked pivot element as 4. Last element we have picked. Last element we have picked as a pivot element, I suppose. So let us go ahead with this. J will be 3, 7 will be compared with 4. So in that case also this portion is false. So then again J will be equal to 4. Value of J is 4, which is 1. Whether 1 is less than 4, when J index is 4, this is getting true. I is incremented by 1. What is the last value of I? 1. Last value of I is 1. I will be 1 plus 1, which is nothing but 2. Remember that I value is 2. Correct? So if it is so, then A2 and AJ will be swapped. So what is the J? A4. So J is A4 will be swapped with A2. I think. So A2 is nothing but 8. 8 will be swapped with 1. So J is 4. Next J is 5. Right? J is 5 means 1, 2, 3, 4, 5. This one. So what I have to do? I have to compare A5, AJ, A5. Okay. and with x is the last one 4. That means 1, 2, 3, 4. 3 will be compared with 4. Yes or no? Which is true. If it is true, it will get inside the loop. I will be incremented by 1. Last value of I is 2. So it will be incremented by I will be 2 plus 1, which is nothing but 3. So once it is 3, then A3 and AJ. That means A3 and A5. A3 and A5 will be swapped. A3 and A5. What is the A3 value? Tell me. A3 value is 7. This is 7 and this thing. So 3 will come over here. 7 will go over there, right? J value 6. I is incremented to 3. Do it. So in that case, 6 and A6 and 4 will be compared again. Sorry, A6 and X. A6 is which one? 5. 5 will be compared with 4, which is false. Nothing is going to happen. J will be automatically incremented to 7. 7 means this one. 6 will be compared with 4. Correct, no? Which is also false. So then what will happen? It is less than equal to. Okay, so in this case what will happen? It will go to R minus 1. Until 7 only it will go. If it is done, then what is going to happen? You have to help me out. Huh? Exchange A I plus 1 and AR. What is the last value of I? That means A4 will be exchanged with AR. AR is nothing but A8, which is nothing but 4. That means A4 value 1, 2, 3, 4, whatever value is there, 4 will be exchanged. So this 4 will come over here. It will occupy this position and 8 will be going over there. It will come over here. So you see this 4, this one is actually having its proper position. That means 1, 2, 3, 4. At the fourth position 4 will be there, right? And then remaining whatever elements are there which is greater than 4, whatever elements left side of the 4 less than 4. Done. So and then finally I plus 1 will be returned. 4 is returned. Okay. So 4 will be returned. Right? So if you run this partitioning, so 4 will be returned here. So this Q guy will be 4. Done. Q4 has got its proper location. Now another call you will be having Quicksort. A, P, 4 minus 1, 3. Fourth position. Correct na? Another one is A, Q plus 1, which is nothing but 4 plus 1, 5. And R, which is nothing but 8. So 2 calls will be there again. Another call will be there. Again you will get 2 sub array. This is how